Hi everybody, today I would like to tell you about the shear forces and the bending moment. Actually, our final goal is to find bending moment inside the beam. Or we can calculate maximum shear forces in the beam or maximum bending moments in the beam. That kind of physical quantity is very important in mechanics of materials. Okay. Now let's think about beam and load and its relationships, reactions. When you see this one, the first one, on the left side, you can see pin joint, pin. And the pin, when you consider a pin, rotation is free at this point. Rotation around point A at this kind of rotation is free. And of course, at point A, movement in horizontal direction or vertical direction or in any direction, the movements in any direction is restricted. But rotation around A point A is available. Now let's think about point B. This point. In this point, movement is free. Movement in this direction. But movement in this direction is not free. It's restricted. Of course, at point B, the rotation is also free. This kind of rotation is free. This kind of beam is, we can say, is simply supported beam. We can say simply supported beam. We say simply supported beam. We can say simply supported beam. In the simply supported beam, on the left side, the pin is freely moved. The pin is freely rotated at this point. Rotation is free at this point. Next, let's think about this kind of cantilever beam. In this case, the beam AB is fixed to the wall. At point A, at this point, the movement in X direction or Y direction is restricted, and rotation is not free. That means when you draw a free body diagram related to cantilever AB, let's draw the cantilever. On the left side, let's say A. On the right side, let's say B. Let's assume some force is acting like this one. If at this point, if it is isolated, then we can draw some kind of free body diagram. Then this kind of a free body diagram is available. Or you can draw some kind of reactional rotation. Okay, this kind of free body diagram is available. But in this case, in horizontal direction, when you consider there is no horizontal direction, then maybe Rx is maybe 0. Or if you have different kind of some forces like this one, then maybe horizontal direction Rx is not 0. Okay, anyway, in the cantilever case, point B is free and at this point is fixed. And when you isolated it, when you draw free body diagram, this kind of forces and rotation is restricted. That's why the moment you can draw for the free body diagram. Okay, next one. In this case, beam with overhang. Overhang is from B to C. That's the overhang. Okay, on the left side, pin joint, pin condition. Okay, rotation is free, and movement at point A is not free. And B point roller, movement roller, same like this one. Okay. If you consider a beam, different kind of condition on the left side or middle or right side is different. When you know what's the difference between them, then you can easily draw free body diagram, and you have very powerful tool to solve problems. Okay, now let's see types of beams, loads, and reaction further. At first, let's think about concentrated load. Normally, this type of load is concentrated load. Okay, concentrated load. External forces acting to a certain point. Compared to concentrated load, we have distributed load. Maybe this kind of one is distributed load, or this one is changing like this one, distributed load. When you consider concentrated load, then you can say it is expressed, the force is, load is expressed in Newton. In the case of distributed one is different. When you introduce some kind of Q, when you introduce this kind of Q value, normally the unit is like this one, Newton per meter or millimeter, Newton per millimeter. That's the way of the quantity of the distributed load. In this case, it's uniformly distributed load because the quantity is, same. Or in this case, it's not uniform load. It's not a uniform load. Okay. If we have this kind of external loads, then maybe you can draw free body diagram or reactional force at this point, horizontal and vertical one, you can say. Or in this case, this kind of rotation is restricted. That's why the reactional moment is applied like this one, and you draw free body diagram. Okay, now let's think about the sign convention related to bending moment and shear forces. At first, let's think about this kind of cantilever beam like this one, cantilever beam. External force P is acting on the left side, P is acting left side like this one. When you consider the distance x, okay, like this one, then when you try to draw a free body diagram, then you can cut this section. Then this part is isolated. On the left side, P is okay. On the right side, the shear force is acting downwards like this one, and moment is acting like this one. If we have this kind of free body diagram, then on the right side, this part is like this one. When you combine both of them, then it's different direction. Okay. When you assemble both of them, then it should be deleted each other. Okay, our question is this direction, phi direction. When you consider a element on the right side, on not left side, right side, then downward direction is positive. And moment, this kind of counterclockwise direction of moment is positive for right side. Okay, now let's see here, this element on the right side. When you think about a element is isolated, this side, right side, downward direction is positive, and counterclockwise direction is positive in the case of moment. When you consider moment, on the left side, upper direction is positive shear force, and clockwise direction of moment is positive. That's a agreement. In some books, this direction is different. But here, in this lecture, I would like to use this kind of sign convention. This one is just agreement. You can change this direction, but when you change this kind of this direction, then maybe some relationship between external force and shear force. Shear force and the relationship between shear force and bending moment. There are some equations related to shear force and bending moment in the external force. The relationship equation is slightly different, especially the sign, minus plus sign, can be changed. Okay, I'll repeat again. When you consider a element is like this one, and separate it. On the right side, downward direction V, and left side, upper direction is positive. When you consider bending moment, this kind of direction, and this kind of direction on the left side, this one is positive. Okay, that's just agreement. For next step, arrangement of formulas. Okay, now let's think about again the positive one, downward direction, and the upward direction. Upward direction is positive, and in the case of bending moment, this kind of shape is positive. We can use. Now let's think about an example. Shear force and bending moment diagram. There's an example. On the left side, pin joint. On the right side, what's that? It's roller. Okay, when you consider this distance, not yet, and there is a beam which has this kind of condition. On the left side is pin, on the right side is roller. Then concentrated force P is acting like that. Its location is A from the left, and A plus B equals L. Okay. In this case, we can calculate RA and RB. We can introduce reactional force like this one. Then, when you introduce some upper direction is positive force, then on the left side, RA and RB minus P equals 0. This kind of relationship is available. And when you draw free body diagram, when you think about this point, this kind of direction is positive. Moment, when you calculate, let's think about around A, this point. Then PA is minus PA, and RB multiplied by L equals 0. Okay, we have two equations. First one, equation 1, and equation 2. Equation 2. We can calculate RA value and RV. Okay. By force and moment equilibrium, we can calculate RA and RB. Next step, let's think about the position X, this position. When you draw free body diagram, downward direction, right side, that's why. Downward direction is positive, and this direction, anti-clockwise, counterclockwise is positive. Well, when X is larger than A, at this point, A, then we can have this kind of relationship. Okay, when X is in this range, X is smaller than A, let's say this case, then V equals RA, right? Same, V equals RA. And when you think about moment around this position, moment M equals RAX. Okay, when you substitute the RA value here, then you can find M value like this one. Of course, we consider this kind of one. Or next one, we can calculate on the right side. When X locates in this range, we can apply this one. When you apply this one, when you apply this kind of relationship, then RA minus P equals V. Okay, we have three different kind of 3-1. And moment M, when you consider around here, then P and RA can be considered. RA and P considered, then you can calculate moment like this one. Now we calculated V and M in the case of this range. When RA is in this range, RA is in this range. Okay, RA is in this range. Slightly, RA is in this range. V value is like this one. You can draw this way. Okay, and if it locates in this range, V value is like this one. Okay, we can draw this kind of diagram. This one is what? Shear force diagram. We can say shear force diagram. Shear force diagram. Next, we can plot bending moment. Okay, when you consider bending moment, on the left side, bending moment is linearly increased like this one. On the right side, bending moment is expressed like this one. And when you consider X value is minus, then you can plot like this one. This kind of bending moment can be obtained, the relationship. Okay, we got this one is what? Bending moment diagram. Bending moment diagram. Okay. We derive shear force and bending moment diagram. We can find. Okay, when you closely watching shear force and bending moment diagram, when you integrate this kind of graph, then you can obtain this kind of relationship. Or when you take derivative of this graph, then you can have shear force. Or when you take another derivative. Okay, when you think about this one, when you take derivative, this kind of relationship is available. Okay. There is some relationship, mathematical relationship between external force and shear force. And shear force and bending moment, there is some relationship. When you take integral one time, once or twice, then you can have different kind of diagram. Okay, anyway, mathematically you can derive it, but we can calculate each step. Okay, now at this point we've considered about shear force and bending moment. In most cases, bending moment diagram is very important, especially this point, the maximum value, maximum bending moment is very important. Why is it so important? When you consider a beam element, it's like this one, beam element. When you think about a cross section of beam element is like this one, maybe we should find this dimension. In order to find this dimension, B or H, this dimension, the bending moment, maximum bending moment is it plays very important role to find this kind of one. Next, in this case, uniform load is considered uniform. I've already told you Q is uniform load, distributed load, and its dimension is Newton per meter or millimeter. When you consider this kind of uniform load, then when you calculate RA and RB value, some kind of imaginary force Q, this distance L, is acting in the middle of the element. Then you can calculate RA and RB value. RA and RB value first. Next, when you calculate shear force, you can cut this amount. Then draw a free body diagram. On the left side, RA, A, and here downward direction is positive V, and this one is what? Moment, bending moment. And distributed load is acting like this one. This one is Q, and this distance is what? X. And equivalent force is acting like this one. This one is what? QX is acting this amount of distance as x over 2 position, x over 2 position. Okay, this kind of free body diagram is available. Based on this point is of course A, then we can calculate shear force and bending moment. And based on shear force and bending moment, we can draw shear force diagram is like this one, and bending moment diagram is this one. When you take derivative of the bending moment, then you can calculate shear force as well, like this one. Mathematically, it's available. And inevitably at this point is maximum bending moment. Maximum bending moment. Okay. In this case, maximum bending moment is expressed with this kind of with this amount. Okay. When you take derivative, then you can have this kind of condition. And when you take one more derivative, you can have this kind of relationship. Okay, linear relationship is available. Okay, that's it. There is some relationship between external force and shear force and bending moment diagram. Okay, in this chapter, it's very important to find the relations or reactions, or to find the maximum bending moment. Maximum bending moment quantity and its position. Just where it happens. That's very important. When you know exactly, then it's much easier to determine the size of the beam element, especially the cross section. How you can make cross section. That's very important. And designing beam elements. Okay, thank you for your